In this episode, we're going to focus on what happens after a release is considered ready, because readiness on paper is not the same as readiness in the real environment. A release becomes real the moment it touches live infrastructure, live data, and live user behavior. And that is where small assumptions can break in ways that tests did not predict. Validation is the operator practice of proving, with evidence, that the release is behaving correctly in the place it actually runs. Smoke tests are quick checks that confirm the system is basically alive and able to perform its most essential functions. Post-deployment tests go deeper by exercising critical paths and integrations after the release has settled into the environment. Hotfix paths are the planned routes for getting a targeted correction out quickly when validation reveals an urgent problem. When these three ideas work together, you reduce downtime, reduce panic, and reduce the blast radius of the inevitable surprises that appear in real delivery. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A smoke test is best understood as a confidence check that the system has not failed in an obvious, catastrophic way. It does not try to prove everything is perfect, and that is a key beginner misunderstanding, because beginners often expect a smoke test to guarantee full correctness. Instead, a smoke test answers questions like whether the service is reachable, whether it can respond to a basic request, and whether the most critical startup dependencies appear available. The name is a reminder that you are looking for visible smoke, meaning clear signs that something is burning, not subtle performance drift. In operational reality, this matters because the earliest failures after a deployment are often simple and severe, like a service not starting, a route missing, or a key configuration value being invalid. If you can detect those failures quickly, you can prevent a bad release from lingering while users experience widespread impact. Smoke tests are therefore about speed and clarity, because they give you an immediate signal about whether you should proceed to deeper validation or stop and recover. Smoke tests must be carefully chosen so they are fast, stable, and representative of the system's ability to serve real traffic. A smoke test that is too trivial can pass while the release is still broken in a meaningful way, and a smoke test that is too complex can fail for reasons unrelated to the release, creating noise and mistrust. Operators tend to focus smoke tests on the minimum set of actions that prove the system can accept requests, process them through the main execution path, and produce a valid response. This often includes a basic read path and a basic write path if the service is supposed to handle both, because a system that can only read but cannot write might still look alive while being functionally useless. Another operational detail is that smoke tests should fail fast, and explain why, because slow failures delay recovery and increase confusion. When smoke tests are stable and meaningful, they become a reliable gate that prevents obvious bad releases from moving forward into broader exposure. Post-deployment tests extend the validation story by focusing on correctness and integration after the release is already in place, because some failures only appear once the system interacts with real dependencies. Post-deployment tests can validate that the application can authenticate to its services, that data flows are functioning, that caching and queues behave as expected, and that key user journeys actually work end-to-end. The important difference from smoke tests is that post-deployment tests assume the system is alive and are designed to prove it is healthy in the deeper sense. Beginners often assume that if a deployment succeeded and the service is up, then the release is valid. But operators know that many failures are quiet at first, like background jobs failing, permissions being wrong, or a critical integration returning unexpected data. Post-deployment tests help catch these issues before they turn into incidents that build over hours. They also produce evidence that the release is functioning as intended in the real environment, which is more trustworthy than pre-deployment confidence alone. A strong post-deployment test strategy acknowledges that time matters, because systems often have a settling period where cache is warm, connections are established, and asynchronous processes start running. If you run post-deployment tests too early, you may get false failures caused by normal startup behavior, which can create unnecessary rollbacks and wasted effort. If you run them too late, You may allow a broken release to harm users for longer than necessary. Operators therefore think about timing windows, starting with immediate checks and then running additional validations after the system reaches steady state. Another practical consideration is that post-deployment tests should cover the highest value paths, not every possible feature, because the goal is risk reduction, not exhaustive retesting of the entire product. That selection is guided by what users care about most and what failures have historically been expensive. When you align post-deployment tests with real risk and realistic timing, validation becomes a steady practice rather than a frantic scramble when things break. Release validation also depends on clearly defining what success looks like, because without a success definition, you cannot interpret results consistently. Success is not only the absence of errors, because a system can return responses while still violating performance expectations or producing incorrect results. Operators therefore think in terms of measurable outcomes like acceptable error rates, acceptable latency ranges, and the correct behavior of critical workflows. Even if you do not use formal service-level concepts, the idea is the same. You need thresholds that tell you whether the release is behaving within the operational tolerance of the environment. Beginners sometimes treat thresholds as arbitrary numbers, but operators treat them as a translation of user experience into measurable signals. If a release introduces a latency spike that makes the system feel broken to users, then the release should not be considered valid even if it technically returns responses. Post-deployment validation is where these thresholds become practical because you are measuring real behavior after the change. When success criteria are clear, decisions become faster and less emotional. Another essential part of validation is separating functional failures from environmental or dependency failures, because the correct response depends on what is actually broken. A release may fail validation because the code is wrong, but it may also fail because the environment is missing a dependency, a permission was changed, or a network route is blocked. If you treat every validation failure as a code defect, you can waste time and push risky changes that do not address the real cause. Operators instead look for clues that indicate where the failure originates, such as whether the failure is consistent across all instances, whether it affects only certain paths, or whether it correlates with a specific dependency. Smoke tests are helpful here because if the system cannot pass a basic health action, the issue may be immediate and local, while post-deployment test failures can signal deeper integration problems. The operator mindset is to use validation results as evidence to classify the failure rather than as a vague message that something is wrong. Classification reduces blast radius because it points you toward the safest recovery path, whether that is rollback, hotfix, or environmental remediation. Hotfix paths exist because not every problem should be solved by a full rollback, and not every rollback is safe or desirable. A hotfix is a targeted correction that addresses a specific urgent defect, often with minimal scope and minimal change surface, so you can restore correct behavior quickly. The word path matters because a hotfix should not be improvised. It should be a planned route through your workflow that is designed for speed and control. Beginners often imagine hotfixing as rushing a quick change directly into production, but operators treat hotfixes as controlled releases with extra discipline, because urgency increases risk. A well-designed hotfix path includes clear criteria for when a hotfix is appropriate, such as a critical bug affecting users or a security issue that cannot wait. It also includes clear rules for testing and validation, because even a small hotfix can introduce new problems if it bypasses safeguards. Hotfix paths reduce panic because they turn an emergency into a known procedure. A mature hotfix strategy also respects the relationship between a hotfix and the mainline delivery flow, because fixes must be integrated cleanly or you will create drift and repeated rework. If a hotfix is applied directly to a running system but not integrated back into the normal release path, the next standard release might reintroduce the original defect or overwrite the hotfix. Operators avoid this by treating the hotfix as part of the version release history, ensuring it becomes a tracked artifact that can be referenced and rolled back like any other release. This also helps with audit and incident review because you can explain exactly what changed and why it changed quickly. Another beginner misunderstanding is to treat hotfixes as exceptions to discipline, but operators treat them as moments when discipline matters even more. The goal is fast correction without losing control over the system's state and history. When hotfix paths are integrated into the normal delivery model, speed and traceability can coexist. Smoke tests and post-deployment tests should be designed to support hotfix decisions by providing clear evidence about what is broken and whether a targeted fix is likely to work. If validation results show a narrow failure in a specific path while most of the system is healthy, a hotfix may be a better choice than rolling back an entire release, especially if rollback would disrupt unrelated improvements. If validation results show widespread instability, rollback may be safer than attempting a targeted fix under pressure. Operators therefore treat validation as decision support, not just as a gate that says pass or fail. They also think about the cost of continued exposure, because leaving a broken release running while you craft a hotfix can increase user harm, even if the hotfix is coming soon. This is where controlled mitigation steps can matter, such as disabling a problematic feature or reducing exposure while you prepare the fix. The operator mindset is to use validation evidence to choose the least risky path to stability, balancing speed, scope, and confidence. When this balance is thoughtful, teams recover faster with fewer secondary incidents. Post-deployment tests also help detect problems that are not immediately obvious, such as subtle data issues, partial job failures, and integration behavior that degrades over time. Some failures appear only when background processing runs, when caches expire, or when external services respond differently under load, and these failures can escape simple smoke testing. Operators therefore treat post-deployment validation as a continuous window rather than a single moment, meaning they pay attention to ongoing signals after release, not just an initial check. This does not mean constant panic monitoring. It means the system should have structured checks and monitoring that confirm the release remains healthy as it runs. A beginner mistake is to stop paying attention once the deployment tool says complete, but operationally the most important period is often immediately after release, when real usage begins to interact with the change. Post-deployment tests, combined with ongoing signals, create a safety net that catches delayed failures early. Early detection reduces blast radius because it reduces the time a bad change stays active. Another important aspect of validation is ensuring that your tests are aligned with real user experience rather than with internal convenience. It is easy to build tests that validate endpoints or components in isolation while missing the way users actually flow through the system. Operators prefer validations that reflect key user journeys, because those journeys are where failures cause the most visible harm. This alignment also improves trust in the validation process, because teams see that the checks correspond to real outcomes, not abstract technical events. For beginners, it helps to think of validation as proving the system can do what users ask it to do, not merely proving that servers are running. This is also where integration checks matter, because user journeys often cross multiple components that must cooperate. When post-deployment tests reflect real journeys, they reveal contract mismatches, permission issues, and unexpected data handling that isolated checks might miss. The result is fewer releases that look healthy to internal tools while feeling broken to users. Validation that matches user reality is one of the strongest reliability investments you can make. Release validation must also be designed to avoid becoming its own source of instability, because overly aggressive testing can overload systems or create false alarms. Smoke tests should be lightweight, and post-deployment tests should be structured so they do not generate large volumes of expensive operations that distort performance. Operators manage this by choosing representative checks that are efficient, by pacing test traffic, and by ensuring tests do not write large amounts of state unless that is necessary and safe. Another operator concern is that tests themselves must be reliable, because flaky tests create confusion and can trigger unnecessary rollbacks or hotfixes. If a post-deployment test fails due to a temporary dependency issue that resolves quickly, the system should have a way to distinguish that from a true regression, often through controlled retries and correlation with other signals. The goal is to have validation that is sensitive to real problems while being resilient to harmless noise. When validation is both meaningful and stable, it becomes a trusted part of the delivery system rather than an obstacle teams try to bypass. A crucial operator habit is to treat validation results as a feedback loop that improves future releases, because each failure teaches you what your pre-deployment confidence was missing. If a release repeatedly fails smoke tests due to a certain configuration mistake, that suggests your build time checks should catch that class of error earlier. If post-deployment tests keep catching integration breaks, that suggests integration validation should be strengthened before release. If hotfixes are frequent for a particular category of defect, that suggests a gap in regression coverage or in feature activation controls. This mindset turns validation from a reactive activity into a learning engine that improves the pipeline's ability to prevent incidents. Beginners sometimes see validation as a punishment because it blocks releases, but operators see it as a protective sensor that reveals weaknesses in the delivery process. Over time, good feedback loops reduce the number of urgent hotfixes because more issues are caught earlier. That is how operational maturity grows. The system gets better at preventing predictable failures, and teams spend less time fighting fires. To close, validating releases with smoke tests, post-deployment tests, and hotfix paths is about building a controlled approach to reality, because reality is where releases either succeed or fail. Smoke tests provide fast, reliable checks that confirm the system is alive and able to perform essential actions, catching obvious failures quickly. Post-deployment tests provide deeper evidence that critical paths and integrations work correctly after the release settles into its real environment, catching subtle and delayed failures before they expand. Hotfix paths provide a planned, disciplined way to deliver targeted corrections quickly when validation reveals urgent problems, without turning urgency into chaos. When these pieces are designed as a cohesive system, they reduce blast radius by limiting exposure time, improving decision-making, and creating faster recovery options. The operator mindset is to treat validation as evidence-driven control, not as a ceremonial step, and to treat hotfix capability as part of reliability, not as an exception. If you can explain why smoke tests are minimal, why post-deployment tests are meaningful, and why hotfix paths must be planned, you have a strong foundation for safe delivery at scale.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.